Welcome everyone. The topic for today is our Bolt Toolkit productivity app, and the agenda is to give a quick overview, introduction, talk about all of the new features in the 2024 release of Ansys and the app, and then specifically walk into how we can use this with the new workflows for big complex assemblies. So a number of nice new improvements, and also do hands-on demo showcasing these best practice on how to go about setting up a model. As a quick starting point, information about our productivity tools is found from our homepage under the productivity tools page here. And today we talk about Bolt Toolkit, and in a month we will also have a similar seminar about the Well Toolkit. Also good to know is our free apps, popular, free to use, and you find all the informations directly from this homepage on our GitHub documentation pages. So here you can already find a lot of questions and answers about the features and functions, and I will get back to this. So starting point for the app, the Bolt Toolkit is an add-on in Ansys Mechanical that lets you quickly set up bolts and rivets and do post-processing, and doing this in a repeatable and easy to use way. This lets you, for instance, deal to create bolts and rivets in a good way, and don't have to deal with CAD defeaturing or contact setup and all these details, but instead can focus on applying familiar properties. And also then the ability to easily extract all the relevant information from the simulation, not just the working load, but shear forces, contact sliding forces, as well as doing assessment according to Eurocode 3 or American Standard AISC, as well as being able to adopt and customize to do other assessments. And the value this brings is, of course, a speed up in model setup and being able to easily manage big assemblies, as I will showcase today. And as I already shown here, you find the documentation available online on our GitHub homepage. So with that said, as a very quick intro, let's look over some of the main new features of the app from both the R1 release and the recent R2 release. So among small and big one of the bigger good things is that the shear force and contact slip force in a bolt result is plotted as a vector to give more understanding. We also have some changes in how you can deal with load scaling. So dealing with pre-tension bolts, you can scale only the change in preload, so you're not scaling the preload in post-processing. Another nice feature starting in 2024 is that you, as a user, will always be notified if there is a new version available, and to know that you're running the correct version for your Ansys version. And also, if you have customized the app, added additional features, there is now an import settings feature, meaning that when you install a new version, a new Ansys release, you can then import your settings in a safe way from a previous version of the app. And finally, we also released a set of tutorials to guide you through how to use this. So all this you will find on this What's New page. So that was before vacation. Now coming to our new feature-packed version for R2 is some changes in behavior, and there is a lot around the user interface and so on. So for instance, bolt pretension is migrated to bolt pretensions group, similar to the simplified and advanced bolts. There are also new group features to deal with visualizations of the bolt, the ID number of the bolt coordinate system, color, translucency, and also an advanced attribute file feature. There is a new rivet type that I will demonstrate, body to body, which lets you have more controls on creating connections between two independent set of groups. And there are other new big features is the automatic hole detection and improved matching of creating bolts and rivets, as well as a set of context actions on how to convert to edge selection, promote to name selection, and adding results easily. And in post-processing, there are also some news how you can set a tolerance factor to filter out and don't show near zero values to focus on bolts or results that are of above a certain threshold. And some automatic filling in of details in the result objects, as well as some news on how you can use this in random vibration or spectrum and model analysis. So a lot of information here. So let's dive into the main part on how this now translates to a better workflow. So one of the workflows that is possible for many years in Workbench is the model assembly. And this is the concept where you can have different independent models, as shown here, a frame, box, and box 2, that can be analyzed independently, but then you can bring them together into a model assembly. So you can do both local analysis of a system, adding, in this case, a static, a modal analysis, or whatever analysis you want to do on the part, and then bring them together, and how the toolkit now lets you control and manage this assembly of components. So one of the nice things here is that when doing the assembly, you can have full control of updating and editing bolt properties, meaning that you can switch between rivets, bolts, advanced bolts, without impacting the previous part. But it's also possible, of course, to go back, redo the analysis of an individual component, and so forth. But that means that if using mechanical the old way, you would have all those properties would be read-only, like connections and so on, when coming to the model assembly. The other nice new enhancement for rivets and bolts is the ability to select faces and bodies and specify to detect holes and create connections automatically. So what we will see here is when editing or creating these load features, we have the dimensions to specify the shaft diameter, hole diameter, minimum and max, as well as the minimum and maximum length for these features. And also this new user interface has not artificial intelligence, but actual intelligence that it checks whether there is already a bolt in a hole, then you cannot use that hole. Or if in the case of a rivet, that you can share one hole between two independent rivets. So the mechanical is aware of this. So about the improved user interface, there are now quick context actions to add results for each of the groups. So if you have a group of bolts or rivets, you can quickly add the strength or result for this. When selecting an individual rivet or bolt, you can then convert this scopings to edge selection or promote to name selections like you can do on normal load features in Mechanical. And then we also have these different groups where you can now control to display the geometry, display ID numbers, setting colors independently. So getting a better control of a model, as I showcase here with the different groups of fasteners. Also mention here about the bolt settings panel. This is where you can manage and setting the defaults. So previously you had to open a text file and setting names and saving that one. That was changed some year back, and this panel now controls how you can toggle and setting default values for all the different items, as well as editing or defining your own materials, rivet bolt codes, or fatigue class. And this has the context here, how you can then easily import from a previous version, resetting to the app default or saving the new defaults. So very convenient way. And also mentioning when using Bolt to Weld Toolkit, you can use the Bolt and Weld report feature from our app report generator. So downloading that will provide you the ability to quickly generate an HTML report. And you can also use the worksheet features that I will demonstrate, where you can see the details and result summary. So that is first a quick overview here of the settings. So now I will directly head over to my live demo. So this is then a new semi-realistic model from GrabCAD, where I will go through some of the choices, how to set this up and run this model. So we will talk a bit about geometry preparation, contact setup, mesh setup, and then coming into, of course, the rivet setup and post-processing, as well as the model assembly part. So starting out here, it's like the when you're having the TV chef. So I prepared a bit. So I have here my project where I have 3 main parts. So let's look on the frame model. So after importing, what I did in Space Claim or Discovery is to define a mid-surface for everything here. So everything is sheet metal, and I've prepared a mid-surface model. One nice little tweak you can do is add a bit of transparency, because that makes it more easy to see all the rivets and joints and so on. So that can be done, as well as, of course, setting the color. So nothing special with that. I haven't really used any shared topology in this case. Since everything is to be bolted, there are a few places where I instead use contacts where you could have used shared topology. I will show that. So coming to connections for this one, I defined a few connections group to bond together a bracket and the beams. And I did another connections group to bond together the edges. And looking at the contact status here, you then see edge-to-edge contacts where we assume welds. And we also see these face-to-face contacts, this bracket that is bonded, welded to the beam. Next up is meshing. So how to mesh this. So a sheet model, what I did here was assign some global featuring, global curvature to deal with all these bolt holes, how to resolve them, but not too much. So quite coarse here, 60°, making it in general good. Face meshing to get a mapped mesh. So here I did select some mappable cylinders, but more importantly, one of the nice newer feature in meshing is to use the prime mesh automatic method. So this controls a new mesh algorithm that will let you use this quad layer meshing feature. And the quad layer here takes input, which is the bolt holes, and I specify here sizing and layer height. And when we look at the mesh, we then get a nice imprint to emulate a washer, or when doing the rivet or bolt setup, we have then a good connection between the bolt and the part. So with that said, we have our geometry, we have contacts, we have the mesh. So now let's go into creating connections. So for this model, I use what's called the rivets. So to create rivets, I can now then go in and say, in this case, select everybody's in the model, selecting a material, shaft diameter, so filling in here these dimensions, and the search distance. It now have detected 42 rivets, and these will become more visible when I click on the rivets group here. And for instance, I can toggle the ID number. So directly a visualization of the shaft diameter, the head diameter. If I, for instance, don't want to use a head diameter, I can directly just fill in the same diameter as the maximum hole diameter. That means that connection is only using the whole edge, the edge of the hole. But the whole idea with this head diameter is to couple around these imprints that the meshing created. And we can of course tune this diameter if you want to slightly smaller, but still connecting these edges. Now I did, as we saw here, the selecting bodies to identify the holes. What we can do is convert this to edge selection. That means that these identified holes are now put in as edges here, and I can now, if I want, edit to unselect, for instance, pick edge filter, so I can manually deselect and remove a rivet from this group. or I simply go back to selecting all the bodies, and it then recalculates and creates the connections again. So with this said, it's if updating the geometry, what we can do here is promote this to name selection. That means that we see here rivets, rivet holes. This is bodies. And what we actually can do here instead is to say everything is called something called mid-surface. So changing this name selection to worksheet, add body name contains like this. So next time you update geometry, this is updated. The rivet groups will take this group and update and redoing these connections. So no more selecting edges or creating these groups. And to finalize this setup, I can use the trick here of re-importing connections. So here I already had created a group, called it frame, and have the different connections in it. And I can now delete my other group here. One of the other features, the body-to-body feature, is where we have then two scopings, a source and a target. And looking into this was used to specifically connect, as we see, the red body with the other part. And in the graphics, we see this as like contact with the red for the source and blue for the target. So this feature will not let you connect within the same body, but only between the two sets. So again, a good way to control your connections. So with that said, what we can now do once this model is set up is to create results. So I can just do like this, create results, and they are automatically grouped, and I can now solve and directly post-process the details of this one. So as I said, the normal results here for rivet are all the forces, moments, stresses, and the utilization factors. So now we've done one model, and let's continue. I want to do a model analysis. So I add in a model analysis. I drag the supports, and I want to reuse these rivets in the model analysis, of course. One way would be to do a pre-stress, but that's not needed. We can instead use what's called a child setup. This now links all the rivets defined from this selected analysis, and we can now solve this model analysis connected with these rivets. Once we've done a model analysis, we might want to do a PSD analysis, for instance. So random vibration, this requires a model analysis. The model analysis contains already the rivets, but for a nice usability tweak here, I also add a child setup here, and this finds the static structural, which is the source of these rivets. And in the random vibration, I can post-process the strength and utilization as well. And there is a nice trick for this, and that is add parent results. So with the click of a button, the exact setup from the parent is duplicated here, easy to use to post-process. So now that showcases the use in a single model. So now let's head over to our model assembly. So I haven't solved it, but here I have linked together all these systems. So what we will notice here is I just not link them together. I also made copies. So looking again at my project page, clicking on the model, we see here the different systems I've linked in and added number of copies. So 3 additional copies of the box 1 and 1 additional copy of box 2 with a transformation to translate them in the assembly. So now we have all the parts linked together. So now we could check here the contact status. So we have the contacts from the frame, and I want to add now the connections. So this is then done in an easy way to use this import feature, and from each of the models I created to save the bolt configuration. So now I just imported it, and it has then automatically assigned the name selections, accounting for the model assembly, so it knows from the different with this additional naming, and it keeping the name. So now let's import the box and import the box 2. Like that. So the box 1, of course, only contained details for one box. So what I can do very quickly is duplicate this one, search for the next scoping here, and as we see, when doing model assembly, Ansys duplicates and creates name selections, as we see here, box 1, box 1, 2, box 1, 3, box 1, 4. And I'm using this in my setup here. Box 1, M6, number 4. And now we have recreated all those connections for those duplicated parts. And finally, I can do that for the last one as well. And doing the trick of suppressing it so I don't get this warning about duplicated things. So now model is ready to run. I have set up my load cases. I have a number of load steps. So again, let's quickly add in the results like this. Box 2, add results, box 1, box 2. And I want to get an overview of all those results. So I do a little trick here, drag and drop them into one group. And I want to create a grouped rivet strength result. So clicking here, this now loaded all the results in the group here, and I can now post-process and get a common plot of everything here. So if I switch over to my pre-solved model, we have results for each individual feature and a group result of all rivets in the model. And here I, for instance, use this tolerance factor to play around and not show everything that is close to 0. To demonstrate, I can reevaluate it, having every result in the model. So this is doing the maximum over time of all rivets in the model. Here is then all the results. And again, to show that if I instead limit the utilization to filter out everything below 0.5 in utilization, we then get a clearer view on where the more loaded rivets are. And we can get a comparison on the highly loaded rivets from the assembly compared to if I go to, in this case, my pre-solved model and go to, this wasn't open, to compare the results from the standalone model. And also what we see in this case here, when this mechanical is launching, so to just show this quickly, so this was the standalone of the frame with the same load cases, and here I have the grouped rivet strength maximum over time, where we see here a maximum of 1.26 and at some location, as we see here, one of the local joints. So again, a good understanding on how a model works in a local analysis as well as in the global analysis when adding other parts. To round up this demo, I had here my static analysis, and to showcase, we could do, of course, a modal analysis. Everything is nicely connected. Followed up by a random vibration analysis, adding a PSD acceleration. We can here get the directional deformation as well as plotting our utilization. In this case, with the 3 sigma probabilities, meaning that in less than 1% the loading might be higher, but this plot here would then show that the vibration utilization is 0.46 at maximum. So in this case, the vibration wasn't a problem, but this big peak acceleration from the static analysis was critical. So that said, demonstrating how we can run and post-process. So round this up by showing the report generator. I forgot to activate it. So let's turn that on. So let's disable some properties here. Filling in some project details. So these project details are linked with the project details we see here in the mechanical tree. So if I want to know about details about this result, I click on this worksheet preview. So this shows me directly all the details selected about the design strength, factors, what result item I'm looking at, and result summary here of all the, as we see here, the loading, the stresses, and the second table for design loads and the utilization factors according to Eurocode. So to simplify this a bit, we could, for instance, add in this tolerance factor, re-evaluate it, and that was needing to rescan the model. And we can also add a figure to prepare this worksheet preview and prepare the Bolt report. So sorry, that wasn't done. So it will take a little while. So that, let's see if I can come back to this final report here. But that kind of rounds off the demo. So thank you for attending and have a great day.